my first two videos on routing, I showed how to use the router in many different ways. And I introduced a variety of jigs and gadgets. Now in this program, I'm going to show you how to make some of these most useful routing aids. Now jigs can be divided into two categories. Those that are used for one-off jobs, such as letting in a small recessed handle, and those that are used continually in the workshop, such as a tenoning jig. Now jigs should be well made and well finished. After all, a jig is a tool, and no self-respecting craftsman would want a poorly finished tool in his workshop. Whilst on the subject of tools, here are a few that you will find useful for your jig making activities. You may have all or many of these, but there are a few specials. You will need a brace and a set of bits, a plane, preferably a smoothing plane, and of course an oil stone to keep it sharp and keep your other tools sharp as well. A straight edge, a steel straight edge, is extremely useful. A set of screwdrivers of various sizes, some bradawls, chisels and possibly a small gouge, file and rasp, a coping saw for small shaped cuts, and a small hacksaw is an extremely useful item, a fret saw, hand fret saw, especially if you haven't got a power one, a large square, a spoke shave, panel saw, reasonably fine, a small dovetail saw, pair of compasses, marking gauge, a combination square, a very useful item, a mallet, pair of pincers, a couple of hammers, a light one and a little heavier one, and some cramps. Of course, with power tools, the job is a lot easier, and they do make for greater accuracy. A power drill, preferably on a stand, is useful, as is a jigsaw. Two machines that are useful for jig making are the bandsaw and the scroll saw. Now, many jobs can be done with the router using the side fence or with self-guiding cutters. But it's not until the router user starts using jigs that the full potential of the machine is realised. Now for jig and template work, the router is guided by means of a guide bush. And these are available in a variety of sizes. Now, a very important point when designing a jig. Take the overall dimension of your workpiece and add to it the difference between the diameter of the cutter and the diameter of the guide bush you're using. For example, a workpiece 100 millimeters by 150 millimeters would need a jig 154 millimeters by 104 millimeters. Now when routing, I always use a sub-table to avoid damaging my workbench. Now the template has been cut out of 9mm plywood and centre lines placed in for positive location. The template size, 154 by 104 millimeters, will give us exactly 100 by 150, which is the desired size. Before attempting to route, I put on my safety glasses. Now this shot clearly shows the difference between the size of the jig and the size of the workpiece. There's a 2mm difference. Thus, the 154 by 104 has given us 100 by 150. Now, if the job is likely to be repeated, it may be worthwhile making a jig to carry out the whole operation. In the case of this doll's house, all the apertures can be cut without repositioning the jig. Now, once the principles of template routing are understood, we can consider jigs of a more advanced type. And the first one we're going to show you is the cross-grain housing jig. Cross-grained housings, or grooves, are frequently used in woodwork. They can be formed by simply tacking a batten or cramping a batten to the workpiece and running the router across. But this method has obvious dangers because the router can quite easily slip. A far better method is to have a purpose-made jig with the router running in a channel. So let's get down to the business of making one. Right, now the first job is to assemble the parts by reference to the drawing. You'll find you'll need a couple of face boards, 2 hardwood edging strips, 2 battens, a small block for underneath the jig, a piece to cut the stop, 3 bolts, complete with washers and wing nuts, and a couple of pins. Now the first job is to ensure that this edge is perfectly straight on each piece. So we should do that by planing them in the vise. Right, now you do the same thing with the other piece and then they're ready for gluing. Right, with the glue on, they are now ready for clamping. If you don't happen to have any clamps, this is a useful substitute. Right, now when the glue is set, the next job is to plane the strips flush. Next, mark the slots in the right-hand piece and route them carefully using a 9.5mm cutter. Note that I've fitted a long fence to the router and override stops to ensure a smooth cut. Screw holes are next bored and countersunk in the left-hand piece. Pins are now inserted in the front battens and filed to a point. These ensure that the jig locates firmly on the workpiece. The left-hand board is now screwed to the battens. Check to make sure that they are square to the running edge. Mark the position of the bolt holes on both battens. And bore and counterbore on the underside. The hole in the slide piece can also be bored at the same time. Fit the right-hand board and check for ease of movement. The top slide has a 9.5mm slot. This piece acts as a stop for the router if stopped grooves are required. The slide piece is now neatly rounded on the bandsaw. The jig is now completed. To use the jig, select a suitable cutter and guide bush. I'm using a 24mm guide bush and a 19mm cutter. The maximum depth of cut of the jig is 9mm. Now the first job is to set the width of the slot with reference to the guide bush. Check it each end, lock it and make sure it runs freely. Then push the jig firmly onto the workpiece, making sure the pins engage, and set the locking board. And the stop. Having set the router to the correct depth, we can cut the groove. The next jig we're going to make is a tenoning jig. Now, tenons are frequently used in all branches of woodwork, so a jig to cut them accurately is an invaluable asset. This jig will cut tenons in material up to 150 millimetres by 50 millimetres, using any router fitted with a suitable cutter and a guide bush. Now, the first job is to assemble the materials by reference to the drawing. You'll find you'll have a baseboard, 2 battens, a running board, a support board, a top board, a plastic overlay, and the necessary ironmongery, knobs, screwed rod, etc. First, check that the baseboard is square. Next, mark the position of the notches in the battens. The bandsaw is best for this job. Check that the running edge of the top board is straight and that the board is square. Screw the hardwood battens in place and check that they are square to the running edge. The plastic laminate is now stuck to the top board. This gives the board a durable surface and a hard running edge. Right, we can set those 2 pieces aside, and while they're curing we can screw on the running board. Next, trim the laminate with a laminate trimmer or plane and file. Now these strips hold the workpiece during the trimming operation. Next, mark out the support board by reference to the drawing and cut the tongues with the bandsaw. The tongues should be an easy fit in the slots. Mark accurately the position of the holes in the top board. Now the next job is to mark the position of the hole in the support board. Notice I'm inserting a packing piece to stabilise the job while the cut is being made. Right, we're now ready to enlarge these holes to accept the T-nuts. The jig can now be assembled with the support board in place. I'm using the spacing piece to locate my top in its correct position. The running board is now checked for alignment. Right, now the jig is finished, so let's cut a tenon. Notice I'm placing a block at the rear of the tenon to prevent breakout. Now the next jig we're going to make is a comb jointing jig. Now comb jointing, or corner locking as it's sometimes called, is a strong and attractive corner joint. With the aid of this jig, the user can form joints up to 150 millimetres wide in material up to 20 millimetres thick. Now first assemble your materials in accordance with the instructions on the drawing. You will need a baseboard, 2 pieces of plastic, a front board, a back board, a running board, a guard, guide pin, a running strip, also a couple of wing nuts to secure the front and rear board together. Start by fixing the plastic to one side of the baseboard. This side should be trimmed before the second side is covered. Both sides must be covered to ensure that the baseboard remains flat. To slot the baseboard, secure it with pieces of material the same thickness. Use 9mm ply running strips to guide the router. This is a jig to make a jig. I am using a 24mm guide bush and a 16mm cutter to cut the slot. The cutter hole can now be drilled. Now to secure the router to the jig, holes are drilled to suit the model being used. Care should be taken to ensure that the cutter is centrally located in the hole. In the case of the LU MOF 96E router, the guide bush can be used to locate the holes. The back and face boards are now taped together and holes drilled in the position marked on the drawing. The holes in the backboard are elongated to allow for adjustment. The backboard is now fitted to the slide board and the slide bar is screwed in place. Care must be taken to ensure that this is square. Next, cut the slot in the faceboard for the guard. The guard is formed from 6mm ply to the dimensions shown on the drawing. The router, fitted with a 1/4-inch 2-flute cutter, is bolted to the baseboard and clamped to the bench. The cutter is set 1/4 inch above the top surface of the baseboard. Now we clamp the faceboard to the backboard, making sure the scribe marks are in alignment. Then we cut a slot in the faceboard. By reference to the scribed mark, move the faceboard exactly 1/2 inch to the left from the operating position. This dimension is critical. Then cut a second slot in the faceboard. Secure the guide pin with fine screws. Don't glue it, then it can be easily renewed. Now bolt the front and back boards together, making sure they line up on the scribed marks. Now to test the jig, prepare a couple of pieces of material about 75mm by 12mm. The cutter should be set 13mm above the top surface of the baseboard. A fine height adjuster fitted to the router is useful for this purpose. Now to make the first cut, place the material against the guide pin and then carry on till the end of the cut. Always lift the material clear at the completion of the cut. Never draw back. To make the second cut, reverse the first piece and place the notch over the guide pin. Butt the second piece up against the first piece and complete the cut in the normal way. If the joint is too loose, move the front board a fraction to the right from the operating position. And if it's too tight, reverse the procedure. The guard can now be fitted and the jig is ready for use. Now there's a great deal of scope when designing jigs for decorative work. Using simple templates and an ovolo cutter, these attractive panels can be formed. You should take care, however, not to make them too complicated. Right, now we're going to make a router table. To get the best out of your router, you need a table to which the inverted router can be attached. The unit I'm going to show you can be made by anyone with average woodworking skills. The best material for this project is MDF, but ply or blockboard may be used, providing it is flat. Right, by reference to the drawing, assemble the following materials. A top, 2 pieces of plastic laminate, piece of 1/4 inch MDF for the router plate, 2 pieces of plastic to cover the router plate, 4 battens, a baseboard, 2 side cheeks, 2 hold down posts, a fence board, a backboard, 2 pieces of material for the hold down springs, materials to construct the dust extraction unit, a rear stiffener and 2 blocks to attach the rear stiffener. You will also need the necessary ironmongery. Now the first job is to neatly round the corners of the top. The next operation is to cover the top with plastic laminate using impact adhesive. Both sides need to be covered to ensure the top stays flat. Next, trim the plastic with a laminate trimmer or with a plane and a file. A 9mm ply template is made to form the table aperture. This aperture is then cut using a 2-flute TCT cutter with a guide bush. This template can then be enlarged to cut the rebate for the router plate. The router plate is made of 6mm MDF, covered both sides with plastic laminate. A hole is bored for the cutter and fixing holes to suit the router being used. Next, mark out and bore the hole for the fence and lateral spring. The base plate is prepared to size. The side cheeks marked from one piece and then cut. At this stage, secure the battens that hold the back stiffener. The fixing battens are drilled and countersunk. These are screwed to the underside of the top and to the baseboard. A piece of ply will ensure correct alignment. The unit can now be assembled, the backboard being fitted for additional stability. To construct the fence unit, start by cutting the slots in the back of the fence board for the hold down posts. Notice I've made a template for this particular job. The fence is now rebaited to receive the horizontal backboard. Next, cut the adjusting slots in the backboard. Notice I'm again using the router with the long fence for stability. Cutter apertures are now formed in the fence and backboard. The hold-down posts are slotted and a half-lap formed on one end. Next, the fence assembly. Glue the posts in place to complete the fence assembly. The rear of the fence can be left open, but it's a better idea to fit a dust extraction unit. Form the slots in the vertical and horizontal hold-down springs by reference to the fence posts and the bolt holes in the table. The fingers can now be cut. These give a certain amount of spring to the hold-down units. And finally, the springs are cut to shape. The unit can now be assembled and tested. The router should be fitted with a fine height adjuster. See how safely and accurately work can be machined using the vertical and horizontal hold-down springs. To make square cuts safely, use a push block. Copper your plane handle for a comfortable grip. Now I'll show you a couple of useful gadgets. First of these is the base extension. This bolts to the base of the router and stabilises it when you're making edge cuts. Now this next gadget is a Perspex centre finder. It has two lines scribed at right angles which, when lined up with similar lines on the workpiece, accurately locate the centre. Finally, just a couple of words about safety. Always wear eye protection when routing. Wear ear defenders if routing for long periods, and some form of dust mask if you have no dust extraction fitted to your router. Now in this video I've shown you some of the jigs and gadgets that can be made for the router. There is great scope for the inventive worker. Don't be afraid to experiment, taking proper care at all times, and good luck with your efforts.